Welcome everyone to Delphicon 2023, when we are celebrating 28 years of our loved Delphi. And in this session we will see how to avoid memory leaks and how deal with Delphi exceptions. And this session was written by me, Maico Dal Ri, and who are speaking here is John, because Michael couldn't speak here today. So, in your agenda, we will see memory leaks. Why do they matter? How to deal with memory leaks. Have memory leaks any relation with exceptions? How we can deal with exceptions? And who I am? Michael Lopez Del Ri, a long-time Delphi developer, senior developer at Acosoft, outsourced company from Brazil, and I am a certified Delphi developer, certified master Delphi developer. Right, so memory leaks, why do they matter? Well, the first thing that we have to put on the table is that who manages the memory of your application? One of the many responsibilities of the operational system is to manage the memory. We are talking about memory, random access memory, memory run, okay? So, Mother of God is this operational system that manages our memory run, okay? And other Mother of God moments in Delphi, we do not have a garbage collector. And if you are a long time Delphi developer, this is not new for you. But if you are a newcomer or if you learned to develop in other language like C#, JavaScript, this information may be shocking to you. But even if you are a long time Delphi developer, stay calm that we will see many things that maybe matter to you too in this session, okay? And just remember that Delphi is very updated. It's a tool that almost every year has a new version. So this whole phrase here is not completely true by now. The true is in Delphi we do not have a garbage collector for Win3264 bits, and that's okay. But for other platforms we have POSIX32 memory manager, right? And this is other thing, and we will not talk about this memory manager in this session. We will only focus on this Win32 and 64 bits and how we can solve memory management problems in this architecture, okay? So, what is memory leaks? Why do they matter in Windows environment, right? Well, we must start with variables. There are nothing but nicknames to memory segments, right? So everyone knows that. And variables, when we choose a class or a class instance, object, we are also using just nicknames to access more complex structures, right? So this is clear to all of us at this moment. But variables are nicknames to memory. We create an object, we fill that memory with a class structure, and when that class structure is accessed by instance of an object, a method calling, or a property setting, anything that manipulates that object pass through that memory that we allocate when we instantiate that object, right? Freeing that object from memory doesn't change the object structure. When we free some memory, we are just telling the compiler that we are not using that structure anymore, right? But we are not cleaning that memory area, right? We are just saying to the compiler, the operational system, that we are not using that object structure anymore, right? So, it gives us two scenarios, right? We have, when we instantiate an object, we have to, after use that object, we have to tell the compiler that we are not using that object anymore, as well as when we want to use some object, we have to instantiate it, right? We have to declare its class create, is class constructor. And if we don't know, if we don't do that, that variable will contains garbage, right? I don't go through stack variables and heap variables. I think that maybe this could be very, very more complex uh, theme for this session. I only will say that local variables maybe will not be initialized, and we have initialized them before we use them, right? Even if we are using that local variable for objects or for uh, object instance, right? And the only type that we do not need to uh, re- we not require the initialization is the string type, right? Well, Uh, usually, then, memory leaks are segments with invalid reference. Like in this scenario here, I have a simple variable and I instantiate some object. I use that object here, right? And after that, I just comment here the free. So in absence of this line, I will have a memory leak, right? Because I are not freeing this object. Of course, your systems are not look like this, right? Like this simple method here, but it's just this step, the first step to we understand what we are talking about. And not free some used memory, that memory will continue being referenced. We must avoid that. But how avoid it? So how can we avoid that in some places of our system, any kind of condition of any kind of behavior of our system, avoid to have this particular uh, comportment here? Well, first of all, we can use report memory leaks on shutdown, right? Is a Delphi native resource. And with this resource, we can monitor our application and see how many memory leaks are available at this moment in our application, right? And if you want to use, if you are already done using this flag, I recommend you to use with conditionals and isolating in a set of debug configurations. So in your release application, you will not have the alarms of some leak has been detected by this memory reporter, right? And this reporter again is a native solution from Delphi. Then we list to us all the memory leaks that we have, right? And in this simple example here, in the next step we will show you the source code. It's very, very easy to see how a leak is generated and how it can be detected, right? And we also has the register expected memory leaks, and maybe we can go around some leak that we already don't know how to solve, but we already can identify where is it that pointer, so we can use this native method as well. uh, let's see this in source code. I put here the creation of my leak object, right? And this method here will instantiate it. And in this step here, I will register this expected memory leak. If I run the application but not click in this button, we will see that after my application, I have the alert here saying that I have a memory leak. And if I run the application, but this time releasing, registering the memory leak in this method here, I will still have the memory leak, but I will not be referenced, right? So if this do not solve the memory leak, why are you talking about it? Okay, because usually, guys, our system will much more be like this. right? If you already don't monitor your memory leaks and you just go there now and put your memory leak reports as true, you will see that maybe if you are not writing uh, a very structured code, you will have a very large list of memory leaks. And this large list of memory leaks is not usually easy to solve, and many times we don't have access to some leaks, we don't have access to some source code that maybe depends on third part code writers. So for many cases we don't have even the ability to solve that memory leak. And for these cases, maybe register expected memory leak can easiest to us. But notice, register memory leaks only work because I know where is the pointer of that leak, right? And usually when we just see the report, as you can see here, we don't have the address memory, right? In the native form of memory leaks, we don't have access to the pointer. So how can we identify what pointer is that? And how can we solve or register that pointer? Well, uh, if you already have some DevOps configured, okay, CI/CD on your development process, uh, usually what we recommend, you freeze these memory leaks, right? You generate a log based on your current memory leak state, and just put on your CD or SonarQube or any other tool that you use to validate your source code, that you will not allow any new memory leak, right? And after that, you go to every new code that you write, blocking, okay, that you will not allow any new memory leak. And with some time, we go back to your previous list of memory leaks and solve each one by one. But again, even with these tools to map and not allow new memory leaks, you still have this large amount of memory leaks, and you have to deal with it, you have to solve it. And how we can identify where is that memory leaks? Well, for identify and solve these particular memory leaks, I will recommend you complementary tools to map and solve these memory leaks, right? With only the report memory leaks on shutdown, maybe it will be very hard for you in a large and a complex system to identify and solve all your uh, memory leaks. And these two blogs posts here maybe help you. This one is from Embarcadero itself, right? And they show how to use the leaker, and even with a small video on YouTube, so you can watch it. It's very simple to install this tool and use it in Delphi to see what line of code generates that particular memory leak, right? And from LandGraph, we have this very complete blog post here that lists many tools to deal with memory leaks, some free, some commercial, right? And all this list of memory leaks tools will help you to identify each line generates that memory leaks, how you can solve it, can generate logs for you from where that leak are being generated. So we'll help you and we'll make the solving memory leaks problem a very simple process, right? So these two links will be in this PDF presentation that I put on GitHub. So when you can go to GitHub, get the source code, you also will get this presentation links and you can access that. So memory leaks related exceptions. Well, uh, as we can see here in this example, many memory leaks also can generate exceptions. If we do not initiate a variable, right? If we do not create the variable here, I can see in runtime, we can see in runtime that this process will generate an access violation, right? And other way that we can maybe or maybe not have uh, an error with related with memory leaks is when we instantiate and we free that object, and after we freed the object, we try to access it again. These are more complex case because of what I told you before, that in this case the memory will not be completely destroyed by compiler in this free instruction here, right? The free instruction only tell that we are not using that memory yet, but that memory will stay in the shape that we create that object. So these source here that are being executed after the free command can it cannot work in this time, will not have an exception. But with a more complex system, with a more complex structure, maybe we can have some access violation in this line here as well, right? And so memory leaks can link us to exceptions, and this kind of exceptions can be hard to find and solve, right? So notice we started with memory leaks or not initiable variables, and we are now dealing with the exceptions that memory leaks can generate to us. And these kind of exceptions are hard to find, hard to solve, because it's not a integer value conversion, it's not a server not found, it's an access violation, and only say that. And we don't have the idea of this memory address where it is to go there and find the solution. And many authors, not computational structure, but just for concept, classify exceptions in at least three types, right? Checked exceptions like file not found, error exceptions like server not found, and runtime exceptions that will go through all these exceptions that we developers generate in runtime. And all these related to memory management exceptions can be put in this particular type here. This particular type we can solve avoiding memory leaks or bad initializations in our system, right? So how can we deal with that? How can we eliminate this behavior from our systems? Well, first of that, we will see that many authors also link exceptions or excess of exceptions with bad performance. Even being a small impact, it has one. So think about it as well, right? And the fundamental way to deal with exceptions in Delphi is through try except block, right? We will not go to every detail of try except block here, but is a more simple way to deal with exceptions. And of course, more complex system, try except block maybe be not enough, will be not enough for us. And what we can do in this kind of scenario, we can use inner exceptions, other native solution from Delphi, so we can easily understand the path that the exception took, right? And we can see this in this exception here, in this process here. Let me just finish my application. And this line here, I was raising a outer exception and putting a new exception on some exception stack that are generated in some other method. Okay, some inner method will raise an exception, and this try block here will catch that exception and put it through the rise with a new exception that I can in a log after this rise watch and try to understand where the exception was generated. And let's see in runtime if it make it more easy, more understand. So here we have one exception, after that other, another, another again, and another on. So this bug has occurred, and I can see all the steps that the exceptions came through, right? After this function call here, this one has generated other method call, and in the finish method call I have just the rise exception. So with inner exception, maybe will not be more easy for us to understand all the pass through that the exception took and go there and try to solve it. Maybe it's more easy to read this than to read just a AV uh, message error, right? And even from the user can read more easily if they see a complex list of what maybe can be wrong, or what option maybe he has took or selected that are not working well, instead of just saying this access violation window here, right? And we also have other native solution from Delphi to deal with exceptions. Uh, that is application on exception event. And this simple here we already are using. It's not our memory leak. And here on the form create, we are setting this event. It's just a simple of object event, right? With a sender and a exception type. And this will be called when every method rise an exception in the entire application component. So in any moment of your runtime life of your system, if this event is present on your application component, and any button click, any event rise an exception, this exception will be directed to this event here, right? And you can going through all the inner exceptions here, and after that generate that list that I showed you before, right? And just please be very careful with this event here to not generate exceptions from this block, right? If you generate some exception in this particular event, your application maybe go through eternal loop, right? So pay a good attention on that. Okay, but this event will help a lot because we'll not have to put it in all method call that we have in our application. It just put on general application component, and immediately all the application exceptions will go through this method, right? Even for writing logs, this event is very good. And talking about writing logs on exceptions, I have this TMS, automated exception log solution to tell you. And this solution will automatically uh, register all exceptions on a cloud provider server from TMS. So if you are trying to deal with some complex uh, errors and you don't have access to many logs, maybe this solution will help you out with that situation, right? And that method call can be put here on application exception. Of course, this application exception will rise for every exception on your system. So if you usually are using exception to just inform simple things on your form validations or any other kind of method validation on your application, all that method will also register exception log on your cloud provider. But you can maybe easily go through that testing the exception type on your own exception method, and only register the exceptions that you wanted to solve, wanted to identify, wanted to understand what's going on, right? Okay, so back to tools that we have to solve exceptions problems. And after that, we go through a small recap. And in this recap, we will see memory leaks must be avoided, right? So again, memory leaks, all the memory that we do not register, we do not read, that we used, will be registered as a memory leak and will stay in operational system memory until the machine was restarted, right? So take care and avoid. Your system can run more slow. Your applications can run more slow with many memory leaks. The operational system can put your application on swap mode, so your application will run more slowly than other applications of that machine. All of that can be avoided if you look out for memory leaks and avoid them, right? We have extra tools that can help us on this path. As I told you and show you the link, Eureka Log, we have MedAccept, we have Leaker, many tools, even free tools that you can use to understand where your memory leaks are occurring and how to solve them, right? And exceptions maybe will be related to memory leaks or bad initializations, right? That a tricky situation because this kind of errors will be usually access violations, right? And access violations are very tricky to solve, to identify, and to correct them. And after that, we have many native ways to deal with any type of exception. Inner exceptions, application on exception event, even the try except blocks from Delphi that we can use. But these other solutions maybe will help you, as well as the more complex solution, even Eureka log or Meta exception log for exceptions. Okay, they work well with exceptions. Uh, they work as well with exceptions too, but for memory leaks detections, I use them on many projects and I see many benefits from using them, right? So really thank you for your attention, and you can contact me at my email here. Here in my blog in Portuguese, but you can go there and write any text in English. I will be happy as well. And all this source code from this presentation, did not go through all the options of my application, but you can find all the source in my GitHub, as well as this PDF of this presentation will be there, so you can go there, download, and access all the links that I put here if any of these tips will help you out to solve your memory leaks problem, right? So thank you again for your attention, and maybe I'll be here to answer all your questions on Q&A session. Goodbye.
Well, that was a good session. Lots of very good comments about it. I've been told that Maico is not entirely confident speaking English because his native language is Portuguese. But we have Dion with us, and Dion is his stand-in. You are the official spokesperson, is that right? You know, I always say this during our live presentations, it wouldn't be right if everything worked completely smoothly. Poor old Jim is having trouble with bandwidth and a few microphones stopped working. Touch wood. No, I'm not going to say it, but I was going to say I seem to be the only one without problems. Of course, now everything will stop working and we'll be in a terrible state. Okay, so I did make a couple of notes. I was trying to find Maico's GitHub. What I did do was note down some of the URLs. Let's just have a quick look at the questions. We've got ages for the Q&A, so I don't think we need to rush too much, and I can probably speak more slowly than I normally do as well, which is a good thing. this is not really a question, but it's more of a statement, which is Gregor was saying he uses Eureka Log, which also catches exceptions and more. Yeah, Eureka Log it allows you to report things like memory leaks as well as catching exceptions and stuff like that. So that is an alternative. I don't think I was doing lots of other things at the same time, so I didn't see Eureka Log mentioned in the presentation, but there is a lot of various options there. What was the other one that I saw? Yeah, someone was saying, another person had said, why is it, there were a couple of answers to this, why is the same code in Delphi 3 doesn't make memory leaks, but in Delphi 10.4, yes, and I suppose the same would be true of Delphi 11. And Patrick did answer that, so I'll just put that up. Things evolve and stuff happens, like people work on components and maybe you were getting away with something before and now they've tightened up the code and it creates a memory leak. Or it could just be that you found a genuine problem because there are a lot of moving parts in the compiler and a lot of moving parts in the runtime and the IDE, so there could be a memory leak. They do lots of testing to try and avoid that. But then a follow-up answer from Patrick was, and also there's a lot of changes because the later versions of the IDE use fast MM, and that was actually what you were showing in the video, I think there, Dion, wasn't it? That that thing where it says report leaks on shutdown is actually a fast MM feature, isn't it not?
Yes.
Yeah, I thought so.
Many new leaks are being reported. Many libraries have leaks, and the reporter did not notice that. And this new version of FastMM and even Oracle or other tools are getting better and better and capture leaks. And even now, Ian, we have many kind of memory leaks like device context, many user operational system resources that you can unlock, and that will not be registered as a memory leak for you. And you can have trouble with that and not looking at your code, maybe generate some leaks that you are not being reported of.
Yeah, and that's the case that you might not have known there was a memory leak, but actually there was, and that could be why. The thing that always, and I feel kind of like developers have a certain responsibility, and I don't think everybody gets on board with this idea that actually, if your program is used on someone's computer, you have a moral responsibility to make sure that you fix memory leaks, because Windows is not very good at coping with applications that grow and grow and grow and steal memory by accident. It's not the case on iOS and it's not the case on Android, because if you've got a memory leak, then the operating system will suddenly start to say, hey, there's something wrong with this application, and clear you out of memory, and eventually it will just say you're a rogue application, and they do look for it in the approvals process. But on Windows, unless you've gone through the Windows Store, and to be honest, the approvals process on the Windows Store is a bit Mickey Mouse, so shall we say? But if you've gone through the process of being tested on Windows, they're probably not going to spot a memory leak, and some of them are very subtle. Because if it's just leaking handles and things like that, it can take a very long time before your application actually impacts the computer. Right. So this is one of the things. But even so, if you're working with bitmaps or working with larger objects that take up a lot of memory, and you leak bitmaps all the time, it won't be long before people think their computer's slowing down, and it's your fault.
And maybe only one process has memory leaks and the entire application. So one day you do not go through that process, you will have no leaks and your application will run just fine. And this is the main cause that makes Maico do this session, because many customers, many clients has this problem, and one day the application just go down. We do not know why going slow. We look having 4 gigabytes of memory allocated on operational system, and the clients go, how can it be? But just one process has the memory leak. So it's very important to monitor all your process to get sure that none of that have memory leaks.
That's an excellent point, and in fact, a kind of point following on that, from that as well, is that once your application starts impacting the system very heavily, or if it's a 32-bit app and you reach a couple of gigabytes, what happens is things stop working in your app, because you go to show something like a button and there's a whole bunch of GDI memory that's going to be used, and things like that, and you don't have enough memory to do it, and so you go to create an object and it fails to create it. And if your exceptions and your handling are not done well enough, and you just assume that every time you create an object it's definitely going to work, then you get even more horrible things happen. Like I mean, it was driving me crazy, because you said you recorded that video, but every time you were testing it was going bing. I'm like, oh, what's happened to I thought for sure.
Sorry about that.
On my
I
computer.
really forgot to put the audio off, and now
I
I
know.
rewatching it.
No, I think it's very interesting. But I started to twitch after all. I'm like, what is broken? What is broken? They've got so
Why
many
I make
apps.
wrong again?
But that's a fact, and the thing that does demonstrate as well the user experience as well, because your end user, if they have things happen and go wrong, and that alert message comes up because you have failed to create something, or you're using too much memory, or something, you run out of disk space, which is a different problem altogether, then they're going to start getting messages like that. It's very quick before someone decides your application is just not worthwhile. And it would really be a horrible thing that you spend all this time developing your application, you polish it, you've got great documentation, you've gone through, and if you're a commercial developer, you've got the sale, and it's very difficult to get the sale, and you've shook hands and everything's great, and 2 months down the line the customer says it keeps eating our computers, it's using all the resources. You've just thrown away all your hard work because of something stupid like you didn't free an object.
And for this session, Ian, I talk about with Maico about dependency injection framework, smart pointers. There is interfaces, many other ways to deal with memory leaks. But Michael told me, let's keep it simple, because if we talk about a very complex memory framework, maybe the normal day developer will say, no, that is not for
It's
me.
too complicated.
Yes, I want to keep it simple. For this presentation, for this session, I want to show simple things, simple way that you, with a simple code, you cannot have memory leaks. You can solve your memory leaks without using smart pointers or other very complex framework to deal with that. And I think that is a great point, and make very reasonable for me when Michael told me that.
Yeah, I absolutely agree. In fact, every presentation I do, I try and make it as simple as possible. I actually go so far as, in my example code, I don't use things like string helpers very often, because a lot of developers are coming from older versions of Delphi, or maybe Free Pascal or something like that. And there are string helpers in those languages as well, but they may look at the code and go, wait, what's this function here? I try and make it as pure Pascal as possible so that people get it. And I think that's a very good point you made, is explain things in a way where people don't say, that would never happen to me because my code isn't that complicated. Yeah, it will. It'll happen to you. Yeah. And the links that I put at the bottom here are some of the Embarcadero blogs as well, whilst we've been talking. And I've also put Wagner's link there as well, which is another one that was mentioned. Wagner Landgraf, he's responsible for, I always forget whether it's Xdata, or I know he works with TMS, so I apologize, Wagner, I should know this. Is actually I get quite well with him, but he's a very smart guy, and his Catching Memory Leaks in Delphi is also a good article. Yeah, okay. Let's have a look where we are with the chat. Did we cover everything? Last 4-star. I don't know whether he was talking specifically about this. He said, but maybe you need to play the theme from Jaws when compiling. Da, 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 something bad is going to happen. But I think that's more for compilation. I think he was talking about compilation errors rather than that. That's the thing with the fast memory manager and the memory leak detection, is that it's not really a compile time thing. That the compiler can do so much and say, it looks like you've done something silly here. You haven't assigned a value to this, or you've used something in a bad way. What it doesn't do, correct me if I'm wrong, but it doesn't say you forgot to free this object, and that only happens really, when you're actually running it. Maybe a more robust sort of static parser would actually go through and say, I don't ever see where this object gets free, but that's what the memory leak detection is for.
SonarQube and many static code analysis tools do that, Ian. So you have many tools to help you. Even the compiler, because even with a variable not initialized, the compiler tells you, but it compiles as well. So you can just ignore the warning and let all the stuff happen.
There's some very well-known component vendors who some of their libraries do that, and it really bugs me, because when I compile my code, I try and make sure I've got no warnings and no errors. And so when the warnings are coming up and they're nothing to do with me, it's very frustrating. But I normally fiddle around with it to get rid of those. But it's one of those things, isn't it? Well, I'm not sure if we've got any other questions. It looks like. Actually, there is a question here. Yeah, Terry was saying it is Wagner Landgraf. Yeah, I know who he is. Wagner is he pronounces it Wagner, not Wagner, but it's Wagner Landgraf. I know who he is. And I don't even know what word that is, UGWeb or something. It would be a great function to integrate full debug mode from FastMM, that's a spelling mistake he's got there, into the Delphi IDE. So if you use the external FastMM library, then there are some conditional compile options that they kind of used a lot with Delphi 7, which is a very, very popular version of Delphi. And you could turn on full debug mode, and then it would report absolutely everything, even things that were not really critical, like a few minor handle leaks and stuff like that. I think, as far as I'm aware, in the IDE, it's kind of doing the next step down from that. So it's reporting anything that you used and then didn't free, or like some assignments. If you do an assignment, you can end up with the memory orphaned and go from there. But I see what you're saying, but unfortunately, it doesn't do that at the moment. Okay, let me just have a quick check with that. Okay, I see. You put up and that was Maico's GitHub. Yeah, I didn't spot that until I went to there. Okay, Martha, I'm going to have a quick word with the producer whilst we're doing it. She's invisible, but Martha, we're probably running out of questions. So if we've got a short video, we'll probably play this in a moment once I've finished speaking to Dion. So if you could just message me in your magic window down here, that would be great. It's like I've got an invisible friend, isn't it? And I'm talking to them. I'm not crazy, honest. It was a great presentation, and I think that it's a subject that it's worth people looking at. A couple of people talking about their favorite FastMM4 options and things like that, and saying there were XE versions that leaked. Yeah, there have been leaks in runtimes and stuff like that over the years. It's frustrating, but it just goes to demonstrate how hard it is. If anybody thinks that they've totally mastered memory management and never get a leak, then by all means start programming in C++, and you will soon learn nothing about memory management, and everything leaks, because C++ is extremely what's the word? Tricky. I think that's the word I'm looking for. I like it. It's a great language, and there's a lot of crossover between Delphi and C++. But Okay, Gregor saying thanks for the presentation. Kevin Bond, Dr. Kevin Bond, no less, one of our guys that was included with the Code Rage, I think it was, Coding Bootcamp, actually, my apologies. Very well-known computer science guy. He's liked your presentation, so that's a big thumbs up from someone who really knows what he's talking about as well. So kudos on both of you.